Hey guys, it's Kaushik over here, and today we are going to start a very important as well as interesting topic, which would lead us to another very interesting topic, which is containers, and then which will eventually lead to Dockers, and then we will go on and see how we use Kubernetes. Okay, so we have interesting things lined up here, but let's just not rush and let's go step by step. So the first thing that we are going to look at is uh, virtual machines. So what are virtual machines and how they work is the first thing that we are going to see. Now, if we just ask ourselves, what is the most fundamental concept behind a virtual machine? The answer is abstraction. So, from the beginning of computer science, each and every invention has been one step forward towards abstraction, one layer of abstraction. So call it a machine, call it hardware, call it software, call it compilers, anything is an abstraction at the end of the day. So in the VM world, what we are talking about here is, let's say that you have a need to support multiple different environments for multiple different application needs. And let's say that one particular application needs to run in a Linux operating system, and then another application needs to run in a Windows operating system, and so on and so forth. And as well as the applications themselves deal with different dependencies. So for example, you have a DLL, a dynamic linked library of a specific version which is used by application 1, which is totally different from the version that is used by application 2, which is maybe in a different operating system. And so at the end of the day, we have different needs, and hence different software versions that needs to be supported. So without a an abstraction, what we would end up with is different servers or different hardware which would be fulfilling each of these needs. So if we have at least two different needs of operating system, let's say Linux and Windows, for two different applications, then we will end up with two different servers. Or let's say if one application is working with the needs of Windows XP, and the other is working with the needs of Windows 10, right? We may end up with two different servers. Okay, so at the end of the day, if we call this version of operating system as an image, then basically what we are saying is that we would need at least two different servers to support two different images of an operating system. Now think of it in a typical environment, in the IT environment, where we need to support different environments. Like the first is something called a local environment or a sandbox, for that matter. And then you will have a dev environment, a development environment, and then a staging environment, which would be swapped with a production environment, which would be assembling the staging environment mostly. And then again, you will have something called a QA environment, and you may have a load testing environment, right? So there are different environments all the way. And these environments would be needing different images of an operating system. And so different versions of the same operating system maybe. And so in a typical world without abstraction, we would end up with at least 3 different servers for supporting development, testing, and production environments. So one server for dev environment, dev server, one server for the QA environment called the QA server, and one for the production server. Now, how this could be fine. However, at some point of time, you would realize that this is a very, very costly option and is not a scalable option, given that you may end up with not one server, but a cluster of servers on each environment, right? So enter the world of abstraction. Now, in this IT world, by abstraction, what we actually are we talking about is something called virtualization. Now, virtualization is basically kind of virtualizing. So what actually is being abstracted over here? So in a virtual machine, what we would want here is that we can't have so many different servers or hardware. So why not have one particular server in which we create multiple such environments? Let's call it environments for timing. So instead of having 3 different servers for dev, test, and prod, why can't we have 3 different environments in one single server? And hence, what that means is, why can't we have 3 different operating systems in one single server? Well, definitely we can do that. And basically, that is virtualizing a server or server virtualization. And that, my friends, is called a virtual machine. So in the diagram which I'm showing you right now, we are seeing 3 different virtual machines. The virtual machine 1 is hosting an app called app 1, and it's actually being hosted by guest OS. Let's call it guest OS 1. And then virtual machine 2 is having app 2, which is under guest OS 2, and 3 is having guest OS 3, let's say. Now, what have we achieved over here is that all our environments, now let's say that the leftmost is the development server, or the development environment. The second one is the QA environment, and the third one is the prod environment. And hence we don't need 3 different servers. We don't need 3 different hardware. We just have all the 3 environments boxed or compartmentalized in one particular server. How is this possible? Well, it's not magic, and it's actually being created or enabled by something called a hypervisor. A hypervisor is something that interfaces between the guest operating system in a virtual machine and the host operating system of the server. And so let's say that we have taken a server which is having a Windows operating system of Windows 10, let's say. However, the guest operating systems in this case may be Windows Server 2016 for virtual machine 1, a Windows Server, another image of Windows Server 2016 for virtual machine 2, and another one for virtual machine 3. So that is, my friends, is the concept of virtual machines, is abstraction or virtualizing hardware or server virtualization.